Okay, let's dive right into this. Picture it. It's early 1969. The space race is absolutely at a fever pitch. And the Apollo program is, well, it's approaching its absolute most critical stage. We're talking about the final puzzle piece before the actual moon landing. Today's explainer is a fast-paced look at a mission that is honestly often entirely overlooked, but it's one that literally held the fate of the entire lunar program right in its hands.
You know, history makes it look like a straight line, right? But what actually made the moon landing possible? I mean, Apollo 7 restored our confidence, sure. Apollo 8 proved we could reach lunar distances, but there was this one massive, completely untested piece of architecture that still remained.
And that brings us to Apollo 9. This was the missing piece. It was an absolutely essential, incredibly high-stakes mission because that untested architecture, yeah, it was the Lunar Module. This strange, incredibly fragile spacecraft, explicitly designed to land on the moon, still needed to prove that it could actually perform out there in the vacuum of space. Without Apollo 9, there is simply no moon landing. It's really that simple.
So here's our rapid-fire roadmap for today. We're going to cover 1. The missing piece, 2. Gumdrop and Spider, 3. The ultimate test, 4. Reconnecting in the void, and 5. The path to Apollo 11. Let's get right into it.
Section 1. The missing piece, the launch of Apollo 9.
The reality was, if the lunar module failed in space, the entire Apollo program stalled completely. No pressure, right? The clock was ticking. March 3rd, 1969, the mission blasts off, launching an incredibly ambitious orbital test. And to get all that heavy hardware into Earth orbit, this mission launched atop the massive Saturn V rocket. This is a huge milestone right off the bat because it was the very first mission to carry both the command and service module and the lunar module together with a crew on board. Just a colossal feat of engineering. Tasked with this monumental job were 3 highly experienced astronauts, Commander James McDivitt, Command Module Pilot David Scott, and Lunar Module Pilot Russell Schweigart. Their job? Oh, just to test every single system needed for a moon landing, but doing it right here in Earth orbit. Section 2. Gumdrop and Spider, a tale of 2 spacecraft. Now, what's really interesting here is that with 2 crewed vehicles in space, NASA needed unique call signs. So the traditional cone-shaped command module became Gumdrop. Kind of cute, right? And the lunar module, they called it Spider. Covered in all this gold foil, it looked so delicate, almost unfinished even. And that's because it didn't need aerodynamics at all. It literally only needed to survive the void of space. Section 3. The ultimate test. Lunar orbit rendezvous. The entire Apollo strategy relied heavily on this exact maneuver. Separate, descend, ascend, and dock. It's like a giant puzzle with absolutely zero room for error. The stakes here are terrifyingly clear. If that docking mechanism failed on a real mission, astronauts are stranded on the moon permanently. No rescue. So Apollo 9 had to prove this procedure could be performed reliably, without a hitch.
What follows is this rapid-fire sequence of high-stress tests. A few days in, McDivitt and Schweikart enter Spider and actually undock. It's the first independent flight. Mid-mission, Schweikart performs a spacewalk to test the life support backpack. Meanwhile, David Scott remains completely alone back in Gumdrop, technically further from his crewmates than any human had ever been at that point. Talk about isolation.
Section 4. Reconnecting in the void. The climax. So, Spider had moved away and proven it could fly on its own. Great, but could they reconnect? That was the million-dollar question. Spider and Gumdrop approached one another and docked successfully. So the crucial point here is that this was the single most important milestone of the entire mission. It officially cleared the ultimate path to the moon. Over the course of 10 days, the crew gathered just an immense volume of data. I mean, they pushed the hardware to its absolute limits, evaluating navigation, life support, communications, the whole shebang. And the results? They were overwhelmingly positive. The hardware worked flawlessly. Having accomplished every single thing they set out to do, on March 13, 1969, the command module re-entered the atmosphere. The parachutes deployed perfectly, and Gumdrop splashed down safely in the Atlantic Ocean, ready for the recovery forces to scoop them up.
Section 5. The path to Apollo 11. The legacy of Apollo 9.
As you can see, Apollo 9 transformed the lunar module from a sketchy theory into a trusted, capable reality. Just look at this breakneck progression. Apollo 9 proves the hardware. Apollo 10 does a full lunar rehearsal, and then straight to Apollo 11, the actual lunar landing.
all of that in a span of just 4 months. Incredible.
When Neil Armstrong and Buzz Aldrin finally descended to the lunar surface in their lunar module, the Eagle, they were relying literally entirely on the systems, the procedures, and the brave, disciplined testing proven by the crew of Apollo 9. The calm, collected professionalism of McDivitt, Scott, and Schweikart contributed directly to the ultimate success of Apollo 11.
Apollo 9 turned the impossible goal of landing on the moon from ambitious plan into an achievable reality. It's just a really powerful reminder that monumental achievements depend on unglamorous, highly disciplined testing. Which leaves us with a fascinating thought. What other forgotten trials in our history are quietly responsible for making our greatest leaps possible? Think about that the next time you look up at the moon.